Something that we can also touch upon is the use of other specially designed primary amines. One of them is called hydroxylamine. This is an amine, a primary amine that has now an hydroxy group attached, and if this adds to a carbonyl component, we form something that is called an oxime. And if we are using a primary amine that has another primary amine attached, and we call this molecule hydrazine, then we, in analogous fashion, as we've seen before with the imine formation, then we generate something that is called a hydrazone. Why is this important? Not so important in today's chemistry anymore, but in earlier times, also 100 years ago and even beyond that, this formation of oximes and hydrazones was very important to identify unknown structures, because the old chemists could use, for example, hydrazine and then react the unknown substance, for example, with the hydrazine. And if it formed a hydrazone, they were sure, okay, there must be a carbonyl group somewhere in this molecule. And by comparing also the melting points of these hydrazones, you can then also identify a substance, because the melting point of a hydrazone is very characteristics for the component. That's why you can still find a lot of large tables of basically melting points of these hydrazone components that were used previously.